This generator simulation is an interactive educational tool designed to help students understand the principles of electromagnetic induction. This simulation allows students to use a tap to run water over a magnet with north and south poles, inducing a current in a coil. The induced current is then transferred to a light bulb and a voltmeter, enabling students to observe and compare the characteristics of the induced current through these devices. This hands-on approach provides a practical and engaging way to explore the fundamental concepts of electromagnetism. This simulation is based on the principle of electromagnetic induction, which states that a changing magnetic field can induce an electric current in a conductor. In this simulation, students control the flow of water over a magnet, which in turn moves the magnet relative to a coil of wire. This movement creates a changing magnetic field, inducing an electric current in the coil. The induced current is then used to power a light bulb and a voltmeter, allowing students to observe the effects of the induced current in real time. Key components of the simulation. 1. Magnet and coil. The magnet with north and south poles is the source of the magnetic field. The coil of wire is the conductor in which the electric current is induced. The relative motion between the magnet and the coil is crucial for inducing the current. 2. Water tap. The water tap controls the flow of water, which in turn moves the magnet. By adjusting the tap, students can vary the speed and direction of the magnet's movement, affecting the strength and direction of the induced current. 3. Light bulb. The light bulb is connected to the coil and acts as a visual indicator of the induced current. The brightness of the bulb is directly proportional to the strength of the induced current. 4. Voltmeter. The voltmeter measures the voltage of the induced current. It provides a numerical indication of the strength of the current, complementing the visual indication provided by the light bulb. For electromagnetic induction to occur, certain conditions must be met. 1. Relative motion. There must be relative motion between the magnet and the coil. This can be achieved by moving the magnet, moving the coil, or moving both. In the simulation, the movement of the magnet is controlled by the flow of water. 2. Changing magnetic field. The magnetic field experienced by the coil must be changing. This change can be in the strength of the field or its direction. In the simulation, the changing magnetic field is created by the movement of the magnet relative to the coil. 3. Conductor. The coil of wire acts as the conductor in which the electric current is induced. The induced current is proportional to the rate of change of the magnetic field. The simulation allows students to observe the characteristics of the induced current through the light bulb and the voltmeter. By adjusting the water tap, students can vary the speed and direction of the magnet's movement and observe the corresponding changes in the brightness of the light bulb and the readings on the voltmeter. The generator simulation offers several educational benefits. 1. Interactive learning. The simulation provides an interactive and engaging way to learn about electromagnetic induction. Students can actively participate in the learning process by controlling the water tap and observing the effects on the light bulb and voltmeter. 2. Visualization of abstract concepts. Electromagnetic induction can be a challenging concept to understand. The simulation provides a visual and tangible representation of this abstract concept, making it more accessible and understandable. 3. Experimentation and exploration. Students can experiment with different speeds and directions of the magnet's movement and observe the resulting changes in the induced current. This exploratory approach encourages critical thinking and problem-solving skills. 4. Real-world application. The simulation provides a practical application of electromagnetic induction, which is the basis for many real-world technologies, such as electric generators and transformers. This helps students see the relevance of the concept in everyday life. 5. Data collection and analysis. The simulation introduces students to the process of data collection and analysis. By observing the readings on the voltmeter and the brightness of the light bulb, students can collect data on the induced current and analyze the relationship between the magnet's movement and the strength of the current. The generator simulation is a valuable educational tool that brings the principles of electromagnetic induction to life through an interactive and engaging context. By allowing students to control the movement of a magnet and observe the resulting induced current, the simulation provides a hands-on learning experience that enhances understanding of this fundamental concept. This interactive approach not only makes learning more enjoyable, but also fosters critical thinking, problem-solving skills, and a deeper appreciation for the relevance of electromagnetism in the real world.